Hello friends of Amautas. For those who don't know me, my name is Javier Santaolalla, engineer doctor in physics and a hyper mega curious homo sapiens who has undertaken this titanic task of reviewing university level physics from scratch in small digestible courses, something approachable and that I hope will also be fun for you. And with this very succinct introduction, we get started and inaugurate a new Amautas course with great fanfare. One also dedicated to one of the things I am most passionate about, gravity. And yes, looking back, what a little stroll we are taking through these gardens of knowledge. That physics with a taste of the honey of eternity. A little walk that, looking back, turns out to be quite beautiful. We started with Galileo's kinematics, continued with Newton's dynamics, Joule's energy, Hooke's waves, and today we stop at a new house dedicated to Kepler's gravitation. Yes, it's true, we're talking about something very close to everyone, very familiar. It is the force we have most at hand, the most popular of all, but also, and this is very interesting, to this day it is the least understood. But let's not get ahead of ourselves. This has been, I admit, an ugly spoiler. Better that you discover it throughout the course on your own. A course that, as I say, is going to be quite lively, and in which I already warn I will raise the mathematical level a bit to cover some very interesting results that will introduce techniques that will later become everyday when we talk, for example, about electricity and magnetism. But to start somewhere, what is gravity? Well, it is the force of attraction between masses. A good starting point, not obvious, which, as you will see, will take us very far. We will discover the origins of gravity through its protagonists Galileo, Kepler, and Newton. We will see how this force governs the behavior of stars, planets, and all bodies in the cosmos. We will also see the appropriate mathematical tools to deal with gravity, such as energy, gravitational force, or gravitational potential. We will study the movement of the planets in their orbits marked by the laws of gravity, and in an advanced chapter we will see how a sphere generates gravity from its infinitesimal components, and we will conclude with a review of modern theories of gravity and the big questions that remain to be resolved. In short, I propose a journey of more than 2000 years from the first humans who looked at the skies trying to find order up there through the great figures of the scientific renaissance to the consolidation of these studies in the modern era. And Poseia. A piece of the journey that will help us become more friends with this companion of our life that marks every step we take even if we don't realize it. A companion whose presence we sometimes don't even notice. And to all this, a special prize awaits. Everything you are going to learn here is exactly what an engineer, for example, from NASA uses to plan a mission. If they are capable of sending a device that lands on Mars, it is because the entire journey is planned through laws. Those laws, my friend, are what you are going to learn here. Let's take another small step through Newton's gardens to be enchanted by its magical melody of the cosmic stuff, which is gravitation. By the way, remember that as always, you can count on Roberto to energize the forums and discussion groups, to propose exercises, to propose exams, and also to answer questions, which, as you know, will also be an important part of this course. Roberto, how are you?
Hello, Motas. Indeed, Javi, I will be energizing the course, answering questions in the forums, posing quizzes, and at the end of the course, I will propose a set of exercises that we will solve in a video. So let's get to it.
Thank you very much, Roberto. I'll see you in the next video.